All right, so today we're going to be working in lesson 6.3, which is working with normally distributed variables. Let me go find where I'm at here, which is working with normally distributed variables. And so this is a combination of the two things that we did in 6.1 and 6.2. 6.1, that section we talked about variables that could be normally distributed, and we talked about how we could standardize them to a standard normal curve with a mean of 0 and then z-scores of 1, 2, and 3, or -1, -2, and -3. How any normal distribution can be standardized in that way. And then in 6.2 we talked about how to find the area underneath a curve that is normally distributed and standardized. And so today we're going to be taking a look at the full picture of what is going on here with normally distributed variables. And we're going to be looking specifically at this variable, IQ scores. Okay, so we want to find the percentage of people. Okay, that's our goal. We want to find the percentage of people that have an IQ score somewhere between 115 and 140. We're going to assume that the mean is 100 and that the standard deviation is 16. So I'm going to do my best to draw this up here. We're going to have a normal curve, and in the normal curve we're going to have the averages at 100, and then we're going to have one standard deviation above the mean, which is going to be 116, two standard deviations above the mean, which is going to be 132, and then three standard deviations above the mean is going to be 148. And really what I'm doing here is I'm just adding 16 each time because that's one standard deviation. So we know that if we were to continue with this, we would say that this has a z-score of 0, this has a z-score of 1, this has a z-score of 2, and this has a z-score of 3. But what we want to find out today is what about the people that have an IQ between 115 and 140? Well, those z-scores don't match any of the z-scores we have here. 115 would be about right there, and then 140 would be about right here. We want to figure out what is the percentage of people that have an IQ score somewhere in this area right here. And so the first thing we're going to have to do is figure out what the z-scores are, the z-score for 115 and the z-score for 140. And so in order to do that, we're going to use this formula. Remember, the formula is that the z-score equals our x minus the average divided by the standard deviation. So with the first one, 115, we're going to have 115, and we're going to subtract the average, which is 100, and we're going to divide that by the standard deviation, which is 16. Well, 115 divided by 100 is 15, and 15 divided by 16, I'm going to have to use my calculator for this. If I take 15 divided by 16, that gives me a z-score of 0.9375. 0.9375. So that's the z-score for 115. And then I'm going to change colors here because now I'm going to find a z-score for 140. And so I'm going to use the exact same formula as what I did here, except this time the x is going to be 140. We're going to subtract 100 and divide that by 16. So 140 divided by 100 is 40, and 40 divided by 16 gives us a z-score of 2.5. So that means the 115, which is here, has a z-score of 0.9375, 0.9375, and the z-score for 140, which is right here, has a z-score of 2.5. And so now we want to find the area between those two z-scores. So this is where we're going to pull out our graphing calculator. So on my graphing calculator, I'm going to go to second vars, and I'm going to go scroll down to normal CDF. This is what we covered in assignment 6.2. So I'm going to go to normal CDF. My lower limit is 0.9375. So 0.9375. My upper limit is 2.5. And so then I'm going to figure out what is that area, which is 0.168. Okay, so that's 0.168, which means that 16.8% of the population have an IQ somewhere between 115 and 140. That's what we're going to be working on today. Let's review what we just did. I'm going to go to the next slide here. So the first thing we did is we sketched a normal curve associated with the variables. And so we started with our normal x values. We changed them to our z-scores. And so that's what you're going to see we're going to do next. Shade the region of interest, and we did that. And then we found the z-scores associated with those x-scores. Okay? And then instead of using a table, we're using our calculator to find the area underneath the curve between those two z-scores. All right, so let's move on. So when we did this, now they rounded it to 0.94 and 2.5 to get their z-score, and we had 0.9375. We just rounded it to a different number. But this is what we did. We found the area between 115 and 140, which was, I forget what it was, 16.8% of the population. Okay, so another thing that is in this lesson is the empirical rule. Now, we've gone over this several times, and we just want to make sure that we understand this. The empirical rule basically has three things that we need to know. First is that 68% of the population is within one standard deviation of the mean. Okay? If we go 2 standard deviations above and below the mean, okay, then we're talking about 95% of the population. And if we go 3 standard deviations above or below the mean, that's 99.7% of the population. So what that looks like is this right here. Okay, so within 1 standard deviation of the mean, we're at 68%. Within 2 standard deviations, we're at 95%. And within 3 standard deviations, we're at 93%. And so now suppose we want to find what is the 90th percentile of IQ scores. And so we're going to do the exact same thing that we did before, except this is kind of the opposite direction. We want to find what range is in the 90th percentile. And so I'm going to go here and let's use red. We know that the 50th percentile is 100. Because 50% of the people would be above that and 50% of the people would be below that. But what we want to know is, what is the 90th percentile? Well, what that means is that 90% of the population would be below it and 10% would be above it. And so I'm going to first find the z-score. I know here the z-score is 0, but I need to know what the z-score is here. And so the first thing I'm going to do is take my calculator out, and this goes back to a 6.2, and I'm going to go to second vars, and I'm going to go down to inverse norm, which is number 3. And I'm going to type in an area of 90% or 0.90, because that's what the area is to the left of that z-score. And so if I type in for the area 0.90 and press enter, it gives me a z-score of 1.28. So 1.28. But I'm not done yet. That's what the z-score is. What I want to find out then is what is the x value? What is the IQ that has a z-score of 1.28? Well, do you remember this formula that the z-score is equal to x minus the average divided by the standard deviation? Well, we know that the z-score is 1.28. We know that we don't know what the x is. We know that the average is 100, and we know the standard deviation is 16. So I'm going to solve this equation for x. I'm going to start by taking 1.28 and multiplying it times 16. So that's going to give me 20.48. That equals x minus 100. Because what I just did is I multiplied this side by 16 and these, and oops, and I don't know how to get that back. There we go. And these 16s cancel, and then I multiplied this side by 16, which is 20.48. Well, then I'm going to add 100 to both sides. So 20.48 plus 100 is 120.48. That means that if you have an IQ of 120.48, you're in the 90th percentile of IQ scores. So there we have it. 120.48 is the 90th percent of all IQ scores. So how we did that, again, we sketched the normal curve. That's what you should always start off doing. That kind of helps you visualize what you're trying to find. And then we shaded the region that we were looking for. Okay, and you can see our work here. We shaded the region that we're looking for just to kind of give us a visual of what we're doing. Now the difference here is we're not using the table. We're using our calculator to determine the z-score by going to second vars and going down to inverse norm. And then the fourth and final step is to convert that z-score into our x value. And that is what 6.3 is about. Hopefully all that made sense, and you can work on 6.3 in Math Excel, and we will go over questions that you have on that assignment when we get back.